I just started recording. There's still people joining, but I'd say go ahead.
Okay, well, welcome to our final official weather discussion of the semester because next Friday is the so-called study day, which is when everybody spends in their entire one day to study for everything they've learned in the semester, which is a kind of a goofy idea. It should be a study week, but every year I take this platform for 5 seconds to say that, but that's all I'm going to say about it. So we won't have a formal discussion next week. I won't be leading it. I'll be grading papers. And so this could be the last one until we reconvene in January. Of course, the opportunity exists that if the weather gets exciting, which we hope it does, we would talk about weather on some Friday during the break, but that's not scheduled. So here's our satellite image movie over the continental United States and adjacent waters for this morning in the last 6 or so hours. And the feature of interest, one of the features of interest that I'll focus my discussion on today, both in the current observations as well as in the forecast, is the emerging sort of leaf cloud that you can see developing here over the southern states, right, and kind of centered on the border between Tennessee and North Carolina at the last image. And this has a very interesting development, not only since the early part of this week, but also it's going to develop nicely into something of reckoning along the east coast of the United States into the weekend. It does appear, I'll just let the cat out of the bag, it does appear it's going to be a little too warm along the coast to affect the megalopolis from Boston to Washington, D.C. with snow, but places just inland may well see some snow, especially higher elevations in Pennsylvania and parts of southern New England, or central and northern New England. So it could be an interesting weekend, first wintry type weekend for a lot of places for the year. And you can see that's really the only game in town over the continental United States and much of continental Canada. The western 2/3 of the country are clear as a bell. We have a beautiful day here, and we'll say a little bit about that in just a minute. So that's the overall picture over the continent, and you get a sense there's something more lurking off the coast. If you go to the far left of this diagram, you see some clouds streaming onshore into central British Columbia. They've been pummeled by one after another over the last 10 days or so. It's been heavy rain up in those locations, snow in the higher elevations. And we'll focus on a storm that will develop out of a very active Northeast Pacific on the early part of the weekend as well. And I want to show you some things. I'm going to do part of it live on GEMPAC to show you how easy it is to really discern the structure of nicely occluded storms. I'm going to show you a little bit of that as we go forward. So that'll be the second part of the discussion. So let's now take a look at our current radar across the continental U.S. and you really can see the S shape almost of this reflectivity band that, as I point out, is kind of centered right at the middle of it is centered over the Tennessee North Carolina border, and there's a trailing band of occasionally pretty intense convective showers here just northwest of Pensacola and then moving into southwestern Georgia, and then a band of reasonably moderate precipitation all the way from just south of Long Island stretching back to eastern Kentucky. So it's a very interesting looking development that's about to ensue in the eastern U.S. The only other precipitation feature of interest, or of any structure and substance actually, is what appears to be some sort of lake effect, enhanced at least, precipitation over western New York State and maybe the far northwestern portion of Pennsylvania. So it's kind of an interesting eastern United States and a relatively inactive western 2/3 of the United States, including our own part of the country where nothing's happening in the sky except crystal clear blue. And that's pretty nice. Somebody had mentioned to me, Chris Glick, who used to be our foundation representative for our department, was writing me this morning saying, has it been sunnier than normal this fall? And I think the first order way to make a determination about that would be to just note that it hasn't rained as much this fall as it has on average. And so it's likely that it actually has been sunnier than normal. And I think his sense jives with mine, even though I don't have any particular observations or statistics to back that up. It sure seems like we've had more sunny days this fall than we often do. So today's a nice example. I want to show you, I'm not going to go to the West Coast yet. I want to show you the complete set of observations about the East Coast event first. Here is a 6-hour forecast of the sea level pressure over the continental United States. So it's not exactly, sorry, let me go back into the zoom in mode. It's not exactly current observations, but it's a 6-hour forecast. And so one can see a couple of different interesting features on this map, and all of them are subtle. Okay, so I want to point out a couple of those. First, here is the forecasted precipitation that more or less is exactly in line with what we just saw on the radar. So this looks like, of course, not surprising, a 6-hour forecast is pretty much on target with where it's raining, not only in this southern United States and middle Atlantic region, but also this lake effect enhanced precipitation over western New York. That's tied to a little weak disturbance in the sea level pressure field, as you can see, about 1,008 millibars. This precipitation feature is not associated with anything that's immediately obvious in the sea level pressure field. These blue lines are sea level isobars. They're contoured every 4 millibars on these maps. And there's no 1,016 millibar isobar. I think this is 1,020 bounding the region of precipitation, and this is 1,012. But if you look closely, you notice in the thickness field, which are the dashed and solid yellow lines with the minimum of 535 right over Cape Girardeau, Missouri, you notice that there's some structure of some upper level wave hinted at by those thickness fields. Given that there's almost no horizontal pressure gradient force, these things look at the surface, that is, the sea level pressure gradient is weak. These thickness lines pretty much dictate or indicate what the 500 millibar flow looks like. And so there's a little bit of a trough. We'll see that that's absolutely right, sitting over southeast Missouri. And down sheer of it is where we start to see this little bend in the precipitation shield, this little S-shaped comma cloud, or leaf cloud, as people have called them before. And that's the beginnings of a development that will actually turn out to be a fairly impressive, explosive development, actually, that will begin to affect the Middle Atlantic and New England states during the day on Saturday. So we'll take a look at how that develops. Yes?
Yeah, I was wondering, the fact that you don't see much at the surface in the vicinity of the upper trough, does that suggest that there's very high stratification over over Missouri, southern Illinois, and Tennessee? So the upper wave can't break down?
It could be. I don't know if that's the case. I didn't look at a prior set of maps to really pay attention to what happens to the higher pressure that seems to be divided by this precipitation band. There's a region of anticyclone high pressure off the East Coast, and there's another one that's built inland over the southwestern states. So the gap in the region of high pressure may actually just say that this is a local low pressure perturbation, and it's in the right place relative to the upper wave. So I don't know if I conveyed that well, but one could imagine this 1,020 millibar isobar cutting right back across to this one and being sort of a fat ridge across the southern states, and it's interrupted by what is beginning to occur in response to this upper wave. That's what I think is happening, but I don't know.
Right. I think also the fact that under the upper wave there's actually a surface ridge axis suggests that the PV associated with the upper wave doesn't have an influence that extends all the way down to the surface beneath it, but certainly to the east of it there may be some hints of an interaction.
Yeah, that's a very good point. And a simple way to interrogate that question, at least to get a first cut answer, would be to just look at a bunch of soundings down over the southern states in the region where you think you ought to be seeing a response to the surface air, because your point's exactly right. If the stratification in the lowest couple of layers of the atmosphere is so high, then it doesn't matter what's going on aloft. You can't make that air move up or down. It's just going to sit there. And when that happens a lot for us in the immediate aftermath of really substantial cold air outbreaks, you can see little ripples come by at 500 millibars, and they do nothing to the lower troposphere because they just can't move the air. The stability is too high. The fact that it's precipitating and that we saw some of those elements looking convective in the radar makes me think there's at least kinks in the armor, or chinks in the armor of that stable layer that might actually be on the ground. So that could be changing as we speak, it looks like. Another interesting feature of interest is also subtle. It's this region of low thickness over northwest Mexico. And that is beginning to spawn this pressure trough over that part of our neighboring country. And that's kind of interesting because that's probably, I don't know how much sensible weather will come out of that over the plateau. It's so dry there, and it's hard to get anything to happen sensible weather-wise except for maybe the pressure falling. But it might be part of a broader tendency to intensify this flow of warmer and moister air off the southwest coast of Mexico. We'll see that that's supported by the subtropical jet. And it's not surprising that this strip of precipitation that's off the coast of Mexico has the orientation it has when you see the 300 millibar and more impressively the 200 millibar flow in just a second. So there's a whole bunch of ingredients conspiring to make something happen in association with this upper wave. And I want to kind of show you some elements of that as part of the observational part of the discussion today. So let's go to 500 millibars, and you'll notice this doesn't look like today's map. It isn't. It's Monday night's map. I think it's Monday, right? Maybe it's Tuesday night. And at that time, at 500 millibars, we had a double-barreled region of low pressure with a geopotential height ridge in between, right over the central portion of the United States. And watch what happens as I page through these at 12-hour intervals to this western upper trough. So first of all, notice that it's characterized over central and eastern Wyoming by very cold air aloft, minus 32. That's cold. So there's an upper trough here. I mean, an upper frontal structure that came around the ridge over southern Canada and kind of emerged in this northerly flow. So watch what happens when we go forward here. You see this broad upper trough being carved out, but it's kind of emphasized on this western side where the horizontal temperature contrast is really staggering. Minus 32 at Grand Junction, Colorado, minus 14 at Salt Lake City. So that's a really, and look at that, 80 knots of wind from the north at Salt Lake, 15, maybe a 5-knot zephyr at Grand Junction. So it's really an intense upper front. And that strong shear along the baroclinic zone is also maintained down here over New Mexico and Arizona. So pretty nice feature. If we keep going, that feature stays pretty strong over Arizona and New Mexico, but look at how the whole upper trough is now beginning to stretch a little bit east-west in its orientation. This is now, I want to make sure of the time, this is now yesterday morning, and you can see this kind of elongated line of shear. The geopotential height doesn't do the justice to the shear. I think you can see, look at here at Amarillo and at Oklahoma City, 180-degree difference wind directions, something quite similar across Kansas and then southern Missouri. And then here you've got El Paso and Midland with winds that are straight from the west, and then winds to the north in Albuquerque and in northern Arizona are also 180 degrees opposite of that. So this is a really strong shear line, it turns out. It's also a region of curvature. And so there's a lot of vorticity associated with this strip that stretches from, let's say, Chicagoland area all the way down toward Tucson. And then this is last night, and you can see that line is even more intensified as the line. Look at this shear between Midland and El Paso. 180-degree wind direction difference over this little thin sliver of the panhandle of Texas. Pretty remarkable. So this is a sharp shear line, but it's also, as I said, it's got some curvature to it. And you can notice the last time, this is this morning. Oh, what happened there? Did I... Is this morning? Oh, that's weird. Let's see. Oh, I don't know what the problem is there. You know what I'll do? I'll just go back and get the 12Z map from this morning, now that you've seen the evolution. So let's do that. Here is the map this morning. No, I had it earlier. This is funny. Okay, rats. Well, I have some other ways to show it anyway. I'm not going to be able to show that the way I hoped. But this morning's map is just a continuation of that, and for some reason it's not loading in for me. Let's take a look at 300 millibars at 12Z. This is interesting. I have that. Very weak 300 millibar winds over the western Gulf Coast of the United States and the northern states of Mexico. We're talking about 100 knots or something. That's a dime a dozen at 300 millibars, and then kind of even weaker as you move to the east all the way to the coast. But if you go to 200 millibars, it's quite a different story. Presuming we can look at it. Rats, what happened here?
I don't know, John. I'm going to try and rerun those real quick. They should be available in a minute or so.
Okay. All right. I bet you I won't even get my 300 back. Nope. So I was lucky to have it just loaded up. But you're going to see that when we go to 200 millibars, oh man, all of a sudden you have this rip-roaring jet. So it's clearly a subtropical jet that's down over the southern states and over the northern part of Mexico. That's going to be on the southern periphery of this development that's going to emerge out of the central United States into the eastern, the middle Atlantic and the northeast coast. So we're going to be able to see that in a minute. Let me go. That's not it. I didn't want to do that. I did want to show I can go here. I'll just show you what the 500 millibar vorticity looks like at the 6-hour time frame, because that's useful to see. And so here it is over the central United States. And you can see that one gets the impression that this feature over Western Tennessee, Western Kentucky, Southeast Missouri, and this feature over the northwest part of Mexico are still connected by a thin umbilical cord of higher than background vorticity. This used to be just a continuous strip just 2 days ago, and these two features have become quite separate, and they're off into their own existences now. And the freedom with which this eastern portion of what used to be a straight vortex line now enjoys is going to be part and parcel of how the development along the East Coast gets initiated. So not until these things could break up was it possible for there to be a little bit of development. Yeah.
I was going to also suggest, I can't recall if you just showed this, but on the satellite imagery, the visible, not visible, the water vapor, often you can see the shear lines kind of devolving into sort of vortex, roll-ups due to perhaps a barotropic growth process. And so I think that maybe what's happening here, and you can see that the umbilical that you're referring to has this slot of dry air, which is also going to be, air of historic origin that is subsided, but has the high PV in it and the high vorticity as well. So
in fact, let's quickly look at the water vapor image, because I was showing the infrared, the non-water vapor infrared. So let's take a look at that.
Like the upper level one, maybe the upper level water vapor.
Okay, yeah. Oh, I hate the color enhanced. I hate it. But it's really good for this. So that shows a really nice picture of exactly what you're talking about. And so you can see this is a line at first, but then Vortex 1 over Missouri, Vortex 2 over northern Mexico, they're separate by the time this even 6-hour movie is over. So it's really nice, isn't it? So that's a great point. And let's see, where were we? We were back here. And so this is what it looks like. This is what it looks like in the 500 millibar vorticity currently. Okay. So this will be the initial condition for looking at the development subsequently in the discussion of this event that's going to get itself organized over the middle Atlantic and eastern United States. And it'll be paying allegiance, of course, to the progression of this upper feature towards the coast. So that's going to be
repeats for today,
issue number one.
Can I point out something? The one thing I'm looking at here is the subtropical jet that you pointed out goes across, it's kind of centered on northern Florida. It goes across.
Yeah, here it is.
It pretty much goes across the entire latitude belt, all the way around the globe, with a couple gaps, and it's an unusually zonal, intense subtropical jet, which is interesting. I don't, it's hard to say exactly why it is, but it doesn't have a lot of deep tropical plumes or anything like that it's pushing poleward. And at the same time, this polar night jet is developing over northwestern North America, and so there's this dichotomy between the polar night jet and the subtropical jet, with very little going on in between, to tell you the truth.
So as best as you can represent it quickly, here's the 200 millibar wind speed from the GFS analysis across the whole hemisphere this morning, and this testifies to what you're talking about, Greg. The only interruption is at about the date line.
Right. Yeah, there's not much. It's unusually zonal.
That's right.
Which suggests to me that there's a lot of energy building up in the tropical belt, a lot of potential energy, because it's not exhausting it in plumes to the poleward direction. So there's a lot of potential building up for something. And at the same time, the polar night jet is very strong over northwest North America, which is interesting now that you're pointing this out, because polar night jet is up in this region where the gap is in the subtropical jet. I don't know why that is. So whatever's happening right now, I looked at the progs, and it seems one thing that's going to happen is you're going to try to build a tropical plume into the eastern Atlantic with this next system, but even that doesn't look particularly impressive to me. So it's an interesting situation. It's like this winter has not released a lot of energy, and it's just building up, is the impression I get.
Yeah. I can't, of course, intelligently comment on that. I don't know exactly the things you're looking at. It's clear, though, you're not looking at what I'm talking about, and so that's no, I'm kidding. But look at the wind speed max in the jet right at the date line. I'll try and zoom in to
Yeah,
get the number right. It's over 200 meters per second. 200 knots, I guess. No, this is meters per second, isn't it, Pete? Oh, knots, 200 knots. So it's over 200 knots. This is an extraordinary jet.
And you know,
that's in the Central Pacific.
in the plot I have, the potential vorticity on the southern side of that jet, in the jet, is 0.
So that's the tropics right at the boundary, or really deep tropics,
it
right at
actually
the
hits
boundary.
0.
Yeah, and that's at about 35 degrees north or something like that. So that's extraordinary. There's going to be ramifications for that. There's no way that won't have some substantial ramification. So,
Hey, John.
Yeah.
Sorry, just another point. The fact that we have that strong subtropical jet across northern Mexico and the northern Gulf of Mexico is actually, I think, helping in some ways to facilitate the change in the orientation or tilt of that upper wave that's over Arkansas and Mississippi this morning.
I completely agree. Yep, that's exactly right. There's a barotropic shear imposed on these things poleward of the jet axis, and they're responding to it, no question. Exactly right. And that, I think, is what's pulling this taffy into 2 separate vortices. That's what you're saying. I agree.
Mm-hmm.
That's exactly right. So really interesting set of things to be thinking about. Okay, so here's the regional view of the 200 millibar map, and look again at 500. We didn't get to look at it. Thanks, Pete, for getting these fixed up so quick. So here's 500 millibars, and there's Vortex 1 and Vortex 2. So later on in the discussion, I'll bring Vortex 1 into the picture for the development. Honestly, I'm not sure whether or not this substantially strong feature over the Great Lakes right now, just to our north and east, is part and parcel of the development there too. We'll take a look at that when we get there. Okay, so that's the beginning of the observations for the eastern part of the domain. Here's the satellite movie over the west coast and the northeast Pacific Ocean. It's a really active period over the northeast Pacific Ocean. It has been all week. We've been talking about it in 452. Yesterday, Maria was able to count 3 or 4 different disturbances in this cloud band that's in the northern Gulf of Alaska now, and they were all very distinct features that you could see. Now there's a whole bunch of places where you can see obviously much colder air aloft. Here's one at about 140 degrees west, and there's a big cloud shield racing toward the British Columbia coast to the east of that. There's another big disturbance getting itself organized near or just to the west or the east of the dateline. Then there's a cold vortex just at the southern end of the Bering Sea. So there's a whole bunch of interesting things going on in the northeast Pacific Ocean. It's a very active time right now. And I want to just show you the synoptic setting in which all of this activity is occurring. This is from Alicia Bentley's maps. This is the 6-hour forecast from the GFS this morning. If the 250 millibar wind speeds are shaded, sea level isobars are the solid black lines at 4 millibar increments, and then thicknesses are drawn in the dashed lines, and when they get to 540 or lower, they're blue. So you can see right at the date line is this really intense cyclone. We're already into the development phase of it. It's in a beautiful spot. It's in the left exit region of the jet. It's got really intense baroclinicity associated with it. It's this feature here that we're going to trace into the future and look a little bit at not only some of the dynamics, but more interestingly in this case, as time will allow, the thermal structure that evolves here. It's really quite nice. And that's where I'm going to go live with GEMPAC and see if it works.
Don, can I point out another feature of that low? I didn't mention before when I was talking about the subtropical jet, but one place in the world that seems to be the most important now, looking at the overall jet stream structure, is around Japan and just to the east of Japan. Mm-hmm. And what's happening there is the polar night jet is superimposed on the subtropical jet. And that's pretty interesting because we know all hell breaks loose when that happens a lot of times. And what you're seeing there, I don't know what's going to happen with this low because I haven't studied it, but if you think this low in the Pacific around the dateline is going to do something, I think that's apparently why. There's something big happening there with this overall structure.
So, yeah, it's right now. At this time, it's at 964. I was just the pause was just me trying to count the isobars. The central pressure is about 964. This thing, it's going to get down in the next 30 or so hours down to 940. So it's a really intense disturbance. And so it might well be this is the beginning of hell breaking loose that you're talking about. So this is the leading feature. This is the leading feature. It's going to, And when you put a low that deep in the Gulf of Alaska, you fundamentally can change the circulation over the whole North America, at least for a period of time. And so there may be consequences to this intense development that take that kind of shape.
I'll point out another thing that's happened this week is the southern hemisphere polar night jet has finally broken up. And so it's just a few pieces, but it's essentially gone. And now we're developing a fairly robust northern hemisphere polar vortex. And the polar vortex, and what I normally see is there's a connection between the polar vortex features at the high latitudes and then the subtropical jet. And right now, that's where they're coming together in the mid-Pacific. And in between, over the last week, I think energy has been building up in the tropics. It's unable to escape to complete the Hadley circulation to the pole. And I say to the pole because that's actually what it does with these jets in plumes. And I think right now, this is going to be a spigot for a lot of energy to come streaming out of the tropics and into the higher latitudes in the northern hemisphere, and it's going to satisfy a buildup that's been occurring for the past couple of weeks. So this could be very big.
Okay, I guess we'll see.
Yeah.
So what I want to do now is trace this thing through the forecast, both of those features. So I'm going to do one at a time, and this is going to be. The first part of this discussion will be the discussion of the Eastern United States event. So we begin right where we ended, the 6-hour forecast of the GFS 500 millibar vorticity. So it's a pretty intense upper vortex. Let me get down for the scale. We're talking about 4 times the Coriolis parameter right here over the Mississippi River in northwestern Mississippi, so associated with this upper disturbance. So this thing is pretty good, and we're going to watch it as we go forward. I think I'm going every 12 hours. Let's see. Nothing seems to be going the way it should have. I'm not sure why. Maybe I had this sitting around for too long. Okay, now it's going. Okay, so this is every 12 hours. That's 6-hour forecast. This is valid tonight at 6 p.m. And you can see the wave going across the southern states. By the time it gets offshore is about 12Z tomorrow morning, and then it's offshore, well offshore in the Long Island Sound region by about 18Z Saturday, so midday Saturday. That's the period of time that we'll look at what's happening to the sea level pressure in this thing. So I'll go back to the original time, which was here. Now, here's the original time in the sea level pressure field, and we already saw this map. Of course, here's the upper wave that we've now seen the vorticity structure associated with, and then here's the S-shaped leaf cloud that's beginning to develop. So let's just step ahead a couple of times. Then it's filing 1,011 millibars. It gets its own little closed-off 1,012 isobar by 18Z. By 0Z, sorry, tonight. And then it's 1,000 millibars. And then it's 994 and 986. And I think the last time I wanted to look at was maybe right here, 983. No, we can just stop at the other one. 986. Remember, it started at 1,011 as a first discernible minimum in sea level pressure that's isolated. That's at 12 hours. And then the 986 comes at 30. So 18 hours later, the thing has developed 25 millibars. That's an explosively deepening cyclone. And you can see the intense precipitation that engendered here along the east coast of the United States, Massachusetts, Connecticut, parts of Maine. It's going to be probably borderline rain, snow in northern New England, and a little bit of snow perhaps in Albany associated with the passage of this very intense cyclone. And I think it continues to develop, although not as rapidly after this point, along the eastern United States coast. And that's all tied to the development, to the progression and interaction between this upper disturbance and what begins to develop here in the lower levels. And you can see that in terms of the relationship between the thickness field a couple of these times and the upper level vorticity. It's very strong PVA by the thermal wind that's driving this development. So I can show you that from what unfortunately is an old simulation. It's from the 0Z GFS simulation. So this would be the equivalent of the 6-hour forecast valid this morning at 8, or valid now about 18Z. And you can see 700 millibar ascent over northwestern Mississippi, and then the strong descent back over Arkansas and parts of Louisiana. And that's exactly in line with where the sea level pressure minimum is trying to emerge. And if we keep going forward, these are at 6-hour intervals. And somehow it's not going forward. I'm not sure why. Oh, I know why. Of course it doesn't do that. I got to do it myself. So then we'll go to the next time, which is 24. That's a 6-hour forecast. This is valid at 6 p.m. tonight. And you can see that couplet of vertical motions quite intense with this development. And then here it is, more intense over eastern North Carolina. Very intense updrafts at 700 millibars, and this is now the 36-hour forecast. So this is valid at 12Z tomorrow, and that's when things are really revving up along the Middle Atlantic, and you can see a really intense dipole of ascent and descent. And notice also, if I could animate it, you'd see it more obviously, the orientation of a line that goes from the maximum subsidence to the maximum ascent starts to rotate cyclonically, and it goes from an orientation that at the initial time is more or less from 9 o'clock to 3 o'clock. At the final time of the development, and I'll go all the way to the end, it becomes 12 o'clock to 6 o'clock. This is characteristic of what happens to these couplets of vertical motion in the context of extreme developments. And I don't have a good answer for that. Why they cyclonically rotate makes perfect sense. They're tied to cyclonically rotating upward disturbance, but why they stop at 12 and 6 o'clock is curious to me. It seems like that's just the limit, how far they can go.
John, I have an idea about this, perhaps. I mean, it just popped up in this case. I'm wondering how much influence the baroclinicity that exists along the mid-Atlantic coast. Early season, the land is pretty cold right now because of the recent colder outbreak there. The ocean temperatures are still warm. That baroclinicity is probably helping to enhance the shear on average in the lower troposphere, and that's going to be directed in a similar direction as the minimum and maximum of vertical motion. So I'm wondering, are these associated with PVA by the thermal wind, the vertical motion maxima, and so it's tied to the shear and the underlying baroclinicity.
Yeah, that's true. But I would say I think you're exactly right about that. But even if this storm were forming and intensifying at this rate over the continent, you'd still see this stoppage at 12 to 6 o'clock orientation. So if you were suggesting it mimics the shape of the coastline, I don't think that's it. But if you're suggesting only that it contributes to the direction of the shear at the right time, that's definitely correct. It definitely does. And that's an interesting aspect of storm development along the east coast of the United States. That's really true. So that's what's happening. Sorry, go ahead.
I was just saying that's an interesting observation, and you're right. Yeah, these do occur even over the continent, so that's certainly not going to be a primary mechanism.
Yeah, I think people who think about occlusions as saturation of waves, like the Hoskins and John Methvens of the world, and those guys who think about stuff like that, they'd probably say right away, well, this is just because the wave and the thermal structure that supports the development of the wave gets saturated. And I guess what they mean is that it folds over itself. And it does. When it gets to the 12 o'clock to 6 o'clock orientation, the underlying thermal field, which is obscured, it's the dashed white, the dotted white lines, but they get obscured by the ascending and descending motions that are portrayed here. They do kind of fold over themselves, and there's just no way to continue to fold anymore unless you cut off, and that's not going to happen. So I don't know. That'd be an interesting conversation to have with people who think that way.
When you get a trowel structure that you've talked about on the backside of a low, isn't that getting past 12 o'clock then for the upward motion?
But the main, still in that case, the main vertical motion couplets don't really budge past the 12 o'clock to 6 o'clock orientation. They still don't. And maybe the actual vertical motion, not the QG vertical motion does, but not the QG. So it's quite interesting. Okay, I'm going to leave that storm unless there's more to talk about that people want to talk about. I want to go to the Pacific Coast and look, not Pacific Coast, the Gulf of Alaska. Look at that one. So we'll have to go back in time at each of these portrayals. I'm going to get my sea level pressure back to 6 hours too. Okay, so here's the vorticity, and at 500 millibars, here's the Aleutian chain that you can see. So the date line's right about there, and there's our upper vortex that seems to be the feature that's associated with the development that will begin to occur here. So let's watch what happens to that upper vortex feature. It's pretty intense, and it becomes I think at the initial time, it's maybe the end of a shear line. And by the time things really get going, it's become a strongly curved upper feature. And look at these heights, 4970 for a minimum in geopotential height at 500 millibars. That's really low. And something's wrong with that map. And it gets down to 4920. And this is a really deep upper level disturbance that's now just south of the main portion of the Aleutian Island chain. And this might be about the time we'll stop looking at it. But you can see it's really well wrapped up and quite intense, almost 4 times the Coriolis parameter for its upper vortex intensity. And if we go to the sea level pressure field at the same periods of time, here's the initial time. We're already at 960. This is what was coincident with the map I showed you from Alicia Bentley's fine suite of products. 960 millibar minimum. And look at the intense baroclinicity back to the west. That's on the poleward side of the jet, of course, and so that it runs right up into the center of the cyclone, and then it's a little bit weaker on the eastern side. Intense precipitation. If we keep going forward, 960 goes to 955, goes to 948, goes to 944, and then 943 at 30 hours. So this is a really intense disturbance. Beautiful cold frontal band right along the leading edge of the cold advection, and then wrapping up into a thermal ridge that somehow gets itself involved in the middle of the cyclone. It isn't particularly obvious what the thermal structure is from just the thickness field. I'm going to show you the 850 30-hour forecast here in this next panel, and zooming in, and you can see this really is a nice, deep, long thermal ridge that goes in, and then there's a little bit of a warm seclusion in the middle of this storm. So it's a pretty intense occluded cyclone by this time, 30 hours in the forecast. Here's our storm on the East Coast at 850. Look at that. Boy, 0 degrees right along the coast. It's going to be a mix of wet snowflakes and rain in the western suburbs of Boston. Everywhere west of 495, Michael, there's a chance for more snow than rain, as you know. So that's going to be the case with that. So what I want to do next is take a look at the thermal structure of this thing that evolves in the Gulf of Alaska. It gets down to 940 millibars. So let me go over here. I think I've got a bunch of pictures. This is a 30-hour forecast from the GFS at 700 millibar theta E, and it's drawn every 3 degrees Kelvin. So here's the thermal ridge, and here's where it gets occluded. This is the occluded thermal ridge all the way back in here. And so what I've done is I've drawn a cross section right through the heart of that thing, trying to be as perpendicular to the ridge axis where I draw my cross section, and when I do that, that tends to ensure that I'm as perpendicular as I can be to both the warm frontal theta E band and the cold frontal theta E band right in the middle of this cross section. So that's what the storm looks like in theta E at 700 millibars at 30 hours. And here's what the cross section actually looks like. And so you get this beautiful occluded structure, comes almost all the way down to the ground. Here's the maximum theta E at the surface. And then it slopes upward and poleward, right like that, as you can see, into the middle troposphere, right up to the tropopause. And this is a region of weakest stratification in the whole storm, in this particular depiction of it, except deep in the cold air behind the cold front. So I like to sometimes look at the topography. I'm sure what we're going to do live, the topography of this occluded structure by choosing appropriately a theta E contour that's right near the warm edge of both the cold frontal and the warm frontal theta E structures. And 312 is a candidate. Maybe you can see those contour numbers, maybe you can't. That says 312. That's a candidate, but it doesn't really seem to adhere all the way along the warm edge of the warm frontal zone, and it might not exhibit continuity in time when I look at more than one of these, and I'm not going to do that today, but if I were to look at more than one, I want to find a surface that I can guarantee is always on the warm edge of the cold frontal zone and the warm frontal zone in the occluded structure. And so I'm choosing 309. And that's going to be the structure, the surface that we investigate in just a minute. But before we do, I want to show you where the model vertical motion is. And so this is the primitive equation model vertical motion at 30 hours into the forecast. And it inhabits this occluded quadrant. It's really intense near the ground, but it inhabits the entire region of poorly stratified air between the warm and the cold front of this occluded structure. This is characteristic of the way these things seem to work. And so if I go to the Alicia Bentley map and go all the way forward to the 30-hour forecast, this is the time that we're looking at. And we had a cross section, you might recall where it was. and I'll help you recall. You don't have to remember. I just have to find it again. Here it is. It goes from just to the southeast of the Alaska border with Canada across the occluded structure. And so that's going to be from about this location straight across like that. And you can see that's right in the thermal ridge of even the 5,500 millibar thickness. And so there's a lot of vertical motion right in this thermal ridge, and that helps to produce the cloud head of the occluded storm. And that's characteristically the case as well. Okay, so there's a really nice picture of how that relationship goes together. Now, what we're going to do is we're going to construct the isobaric topography of the 309 Kelvin theta E surface over this domain, this domain right here in the Gulf of Alaska. So that's what we're going to do now, as long as this works. It looks like it will. Okay. All right, I'm going to, what happened there? Restore last. Come on, don't be fooling with me. It's fooling with me. Okay, so what are we going to do? We're going to just get the right data set in there. 2012-04-12 aviation 03.gem. G func is theta E. G level's 1,000. I don't have the same. Luckily, I wrote down the area. 160, 70, minus 120. And then projection equals MCD. Let's see, panel equals nothing. Title equals nothing. Text equals 0.5. Let's see if this is going to work. And then 30-hour forecast. What? This is the danger of live TV.
You're a man, John.
I tried it all out before, you know. I mean, I just made it work. Okay, I know what I did wrong. Now
Capital.
we're just going to, nope, we're going to do 309, 309, 309. We're only going to be doing the 309-degree Kelvin theta E isentrope. This time it's at 1,000 millibars. So that's what it looks like. I need a map. That's what it looks like at 1,000 millibars. Okay, now we'll do 900 millibars. And use a different color and don't clear the old one because we're going to build a map on top of itself. So there's 900 millibars. Let's do another one, 800. Start to see a structure emerge. 700 millibars. Oh yeah, look at that. 600. Oh, well, it's coming out. And that's the 500 millibar line, and then we'll do 400 and 300. That's 400, and I don't think there's much for 300, but we'll give it a try. Yeah, so we really end up, the structure ends at about between 400 and 300 millibars. But look at this now. We've constructed the topography of the 309-degree Kelvin theta E surface at that 30-hour forecast time. Look at how steeply sloped the cold front is. These are 100 millibar increments, and they're stacked on top of each other until you get way up in the middle troposphere. And then the warm front's a little less steeply sloped, and look at this occluded thermal ridge. You just can't miss it. It comes right out of there. Now let's put some quasi-geostrophic vertical motions on top of this and see what they look like. So I have to do some more work on this, and I just got to change the file. Let's see. And it's 2012-0400. Let's put the total quasi-geostrophic vertical motion on there. And we'll put a scale equals 1. I don't know what color I'm going to use. I don't have any left. 20. See how it looks. So this will just be the, what happened there? I'm a little bit confused. Anyway, I guess I'm not going to get to that last part. I tried that out too. And
Did you want to
it's
just hit enter? Did you not hit enter? Hit carriage return.
Yeah, I don't have, it doesn't look like I have very much vertical motion. I know this can't be right. It's more intense than that. So that the contour interval is not the problem. It's the values. Oh, it's the level. Okay, I'm going to show you 700 millibars. That's what it is. Okay. Oh yeah, more than. So there's our QG vertical motion, and look at it's right in the occluded quadrant. That little piece is right in there. It's just perfect, isn't it? How it aligns, just absolutely perfect. Let me make that a little bit thicker. Line equals 4. No, 1. Might be easier to see. Yeah, I think you can see it a little bit easier then. There's a really beautiful hook at this stage in the cyclone life cycle. 700 millibar quasi-geostrophic vertical motion is most intense right in the occluded quadrant. And we could go on and split this up. It's going to be hard to do because I can't recreate the underlying map more than once. I have to do it the longhand way. But it ends up, when you split this into the piece that's associated with the along isentrope Q and the part that's associated with the frontal across isentrope Q, the largest piece is the along isentrope Q. It's almost the entire thing, as it turns out. And it's consistent with all the stuff that I'd learned some years ago. But this is really nicely illustrated in this storm. And it's just, picked at random. It just happened to be an interesting storm to look at. And the whole thing falls together like this really nicely. So, and I'm kind of showing this. I know there's not probably a lot of people in 452 out there, but there are from 751 students. All it takes is some curiosity and some willingness to make mistakes with GEMPAX or whatever plotting program you're using. And you can start to see these relationships, and they bring to life the nature of these weather systems in a way that no other, exercise really can. And I think it's quite exciting to see these things in real time and in real life, especially when someone's on the line creating it for you right in front of you and it works out. So that's all I have for the discussion today. But I'm happy to take any questions or comments. Are people still there?
Yeah, we're still here.
Oh, okay.
Somebody asked me the other day, what are the chances we have a white Christmas this year? I think they're pretty slim.
I do too, Pete. Let's have some fun.
Yeah,
we can use
Michael's Fantasyland here.
Yeah, we can do that. We can do Fantasyland. Let's do it over North America. I think we can do it almost that far out with Alicia's maps. I don't know if that's true or not. Let's see. I don't want that. Let's see. Where is the variables? Is Michael trying to convey something? Here it is. All right, so we're going to just go wild. There's our storm off the east coast of the United States. This is a Saturday-Sunday event. Pretty exciting. Very heavy precipitation. Here's the Gulf of Alaska event. And notice the heavy precip that's forecasted in the occluded quadrant. We just diagnosed some of the, at least elements that are involved in that. And I think the next storm off the east coast is right there. That's a pretty intense event. That's the 9th of December, but it's well offshore, so it's wasted on the fish, as Lance Bossart likes to say. But it's pretty intense. Well, there's no fish that live on the shore of Newfoundland. I mean, they're going to get something pretty exciting out of that. So the dashed lines here are isotherms at 850. So they get 0 and colder is blue. So it's snowing there. Here we are out to the 9th of December. Nothing's happening. It hasn't even precipitated in Wisconsin over the last 10 days. Gets us only to 12th of December. We don't have anything there. So we got to go somewhere else for Michael's fantasy 720-hour forecast.
Yeah, Pivotal will have it.
Okay. All right, models. All right, so we can go. Is this right, GFS? Everything about this is right? Okay, let's get precipitation type and rate. That's on. Okay, so we'll just march forward. Wait a minute, how do you do that here?
You can go actually. Yeah, you can march forward that way. Yeah, you can do it that way.
This way here? Taking too long. Let's just do it at increments.
Right.
All right, so here's 5 days. This will be valid at 9th. We already kind of saw some of that. Here is 10 days. Whoa, maybe we get a little flurry of snow on the 14th, or the 14th at 12Z. But the main event is further to the east. I guess this mandates that we look a day earlier than that. Oh, that looks kind of interesting. So here's the 216-hour forecast for next Sunday that has a really wound up storm just to our south and west, but it's taking the wrong track. It's going to go, it looks like it's going to go straight from southwest Missouri to the upper peninsula, which means mostly rain for us out of that one. Okay, so that's out.
Yay.
288. Nothing at all happening here by the 16th. Let's see. 348. Popcorn cumulus along the central Gulf of Mexico coast. Nothing for us. 19th. 384 hours gets us to the 20th. A featureless region of weak snow where the pressure is 1,020 millibars. Wow, that's weird. Interesting, but weird. And then an East Coast storm with very cold air sitting poised over New England with the anticyclone. This looks like the perfect situation for an extreme event in the week of Christmas for the eastern United States, not for us.
If you want to go further out, you can go to change that GFS to CFS.
Okay. Come on, why is it doing that for me?
Slowly bring it up there. Yeah.
All right, CFS.
First one at the top. Quick, yeah.
So this is 396 hours. Let's go to 420. What is this? 10-degree resolution or something? This is 21st.
That's probably 1 degree or so.
That's not 1 degree. That is not. This is the cartoon. Huh? Look at this. Nothing. 24th. We're past Christmas here, and we get on this Christmas morning, a little flurry of snow over the field of dreams. And maybe we'll see it later in the day. But this is only 516 hours out, so I'm not sure we should really worry too much about that. And what about 700? Huh?
I was going to say we're far enough out that if you wanted to go back to Christmas Day, there's a feature they have that allows you to loop over all the forecasts valid at the same time to see how that forecast is.
All right. What was that, 528 hours about?
Right.
How about 516? This is Christmas morning.
Yeah.
Okay, how do you do that?
So go to single image at the top. See that?
Yeah.
And then you do model trend loop. It's the second one on the left down.
Okay. Oh, this will be good. So this is all the forecasts valid at 12Z on Christmas morning. That
Right.
This first one is 648 hours, and they're shrinking by 12 hours of forecast time all the way through.
Right.
Okay. So if you look at Wisconsin, there's one event. Let's see which one it was. Right there. Okay, this is a 600-hour forecast made on the 30th of November that gave us a chance for some snow on Christmas morning. That's it. Okay, there's nothing else in the deck of cards. It's terrible. But this is, cartoon land. But nonetheless, there's only one event.
And as we get closer to the event, obviously you'll have more model runs, and you can begin to see what the trend actually is in terms of, is there going to be a lock-in for us to be cold or warm, sunny,
Yeah, so right now there's one chance, and it's or one card comes up the way you want it, and that's it. So I'd say, Pete, the chances are pretty slim, at least according to available guidance.
Yeah, that was sort of my feeling as well.
Unfortunately. Well.
Hey, John, just one other point. Yeah, thanks for showing that demonstration of GenPack. Those that are in 310 are beginning to explore a little bit with GenPack, and they can sort of see how rapidly you can begin to interrogate a data set pretty easily. It's a really great tool to learn, and so just encouraging students to explore the tool as well as the data that we have available. That was a great example.
I agree with that. You can even solve Poisson equations with the GenPack package.
Yep.
As we've shown each other in the spring, so.
Sometimes.
Okay. Well, everybody have a great weekend and a wonderful holiday. Work hard to get through finals, and we'll reconvene for sure on the 8th or 29th of January, probably the coldest day of the year. Hopefully we'll have the lowest thicknesses and lowest 850 temperatures of the whole year to talk about on that Friday. And
Okay, John.
Yeah.
John and Pete, very quickly, and Greg, flash forecast for how much snow will be on the ground at Weather Watch time in our first Weather Watch in January.
Oh, excellent question. Okay, I'm going to say there'll be 10 inches of snow on the ground, and we would have had one 6-inch snowfall event by then.
I'm going to say 4, and we will not have any over 4 inches. This will be just dribs and drabs.
I was going to say 2 with a layer of crusty yuck snow on top from the January thaw that we've had just before.
That's a good one, Pete. I hope
And
you're
Greg?
wrong.
And Greg?
He may have already left with his class. I don't know.
He's muted, though.
Oh.
Okay. Well, we have the numbers. It's
I'm
recorded.
going to go for 0.
0.
Whoa.
Oh my God.
That's
Iconoclastic to the end.
That's bold.
Greg, you're my hero. That would be awesome.
Can't help himself.
That's a bold forecast, Greg, but
It is very bold.
not out of the realm of reality.
It's not that terribly
No, it's
unusual
not.
for us for January.
Right.
For January.
I know.
You get a thaw, it's
That is
gone. I mean, it could be 0.
Yep. It
Right.
could be. It's
thaw
not
is-
crazy.
See it on the plots that Ed makes. You know, if you average daily, there's like right around January 20th or 22nd or something, there's a definite peak.
Yeah. Yep.
Peak in snow depth?
No, in temperature.
No warmth. Yeah.
Yeah.
Let me see if I can pull that up real quick and share it. Hold on.
That's actually
But
would be an
you usually
interesting.
get those thaws after a cold winter, and this one's starting out pretty warm. So I don't know.
Yeah, that's
It'd
true.
be interesting to see a chart that shows for each day of the year how much snow on average is on the ground and what the variance is for that day. I wonder if the state climatology office has something like that.
Yeah, that's a really good one. I don't know. I bet they don't because it's a little bit nuanced, but it's really interesting. Or I wanted
It's
to
not
have the
working.
calendar. I wanted to have the calendar a year with the difference between the all-time maximum and the all-time minimum on each day. See where that gets biggest. I think we're in the season right now where it does. We might be just trailing away from it.
There was a CFS forecast a few days ago that had it. And this was again out in Fantasyland. That was, I think, had us approaching the low 50s in late December or early January.
Really? Wow.
Yeah,
Unbelievable.
sign me up for that.
Well, and then the other question, a related question, I think we entertained this at one time last year. Something about, might have been how many days of the calendar year do you actually experience on average a minimum daily temperature that exceeds the average daily high? It seems to me that never happens in the summertime, but it does happen in the wintertime. So I wonder what the distribution of that is.
Yeah,
Mhm.
that's
All right,
It'd
I
be kind
think
of interesting. We did that in early November. We did that during our warm spell in early November. I think it was on the 9th or 10th. Our overnight minimum was higher than the daily average high for that same day. So that was incredible. Okay, I think, well, there it is, Pete.
this is the one. So I think it's right. This peak right here is what I'm talking about, like January 20th. So these are the days. If you take the last 30 years of temperature data and average it by day and don't smooth it at all, this is what it looks like. And this peak right here, I think, is the January thaw. You're not seeing it?
I just have your face frozen.
No, I see it. I see
I can
it.
see it. Yeah.
Anyways. You can see it in the lows, too. There's 2 of them. It's like one January 10th and another one around January 20th.
Well, Pete, thank you for the whole semester of setting up and broadcasting and being available for all kinds of other technical questions. Greg, thanks for your constant contributions. And Michael, it's great to have you here today. Maybe we'll see more of you in the spring, although you'll have new duties, I suppose. But it's been a great semester, and I hope everybody's taken something away from our discussions and looking forward to next semester already, especially since there'll be guaranteed winter weather. It won't be any more of this tropical nonsense.
Sounds good.
come
Well,
on.
You better hope that's not true, John, 'cause the tropical stuff is driving the winter weather.
I think we'll have at least one more named TC before we resume classes.
Oh, really? Wow.
That's not going to
In
happen.
the Atlantic.
Okay.
All right.
Those two with Angela, because I know this will be a required part of 752.
Yeah, that's right.
So we'll
Yeah,
touch
we
base
have
on
to
that.
talk about that.
If we end up doing it online, I think we'll maybe consider doing it in Zoom rather than Blackboard Collaborate, as we're going to do with the colloquia and seminars too. So
Yeah. Okay.
that I'll put that information out on to everyone at AOS and the Facebook and Twitter links too. So
All
have a
right.
great,
Sounds good.
and we'll see you.
Thanks,
If we do
John.
have these, we'll let you know.
Thanks, John.
All right. You bet. We'll see you all later.